square matrix is a matrix with the same number of rows as columns. The identity matrix I subscript n is the n by n matrix for which each main diagonal entry is a 1 and for which all other entries are 0. So I1 would look like this, I2 would be this, and then I3 and I4 look like this. So there's this diagonal of 1s, and every other entry is 0. And if you multiply a matrix A by the identity matrix, then you just get matrix A back. So the directions say use the calculator to perform the multiplication. So I'm going to enter in the first matrix into matrix A and the second matrix into matrix B. And then if you multiply A times B on the calculator, then you will get matrix A. So we multiplied by the identity matrix and we got the same thing back. Question 2, we're multiplying the same two matrices just in the reverse order. So I already have the 3 by 3 identity matrix in matrix B on my calculator, and I already have this matrix in matrix A on my calculator. So if you just do matrix B times matrix A on the calculator, then you get the same thing. So this shows that it doesn't matter if the identity matrix is on the right or on the left when you're doing the multiplication. You get the same thing. And that's definitely not what usually happens when you're doing matrix multiplication. Usually the order is very significant. And then lastly, on number 3, if we enter this into matrix A and then the identity matrix into matrix B, then AB is just A.